So we have completed trigonometric basic ratios. We have completed trigonometric ratios of some specific angles, namely 0, 30, 45 degree, 60 degree and 90 degree. Then we have done complementary angles ka trigonometric ratios. Now the fourth concept is trigonometric identities. Trigonometric identities. Just as we learn algebraic identities, a plus b the whole square, a minus b the whole square, a cube minus b cube, these type of identity, a plus b the whole cube, a minus b the whole cube. The same way trigonometry has also got identities. This year, 10th standard, we are dealing with only three identities. Those who are taking mathematics, next year you have to learn a lot of identities, lot of formula. But this year we are learning only three identities. This three identities very easy to understand and you have to learn it by heart so that we can apply it in the sums and prove it using identities. Let me come to the first one. Let us consider a small right angle triangle, namely ABC. I am giving this angle as theta. I am giving this side as A, this side as B and this side as C, the length is. Now, let me write what is sine theta. You know, sine theta is opposite side by hypotenuse, which is nothing but C upon B. Now, what is cos theta? Cos theta is theta's adjacent side by hypotenuse, which is nothing but A upon B. We know the basic ratios. Now, let us write what is sine square theta plus cos square theta. Sine square theta will be C square upon B square and cos square theta will be A square upon B square. Denominator is same B square. I am just adding the numerator C square plus A square. And you know, according to Pythagoras result, C square plus A square is equal to B square. So I am getting B square, this is B square, C square plus A square. B square upon B square is equal to 1. This is the first identity, which is sine square theta plus cos square theta is equal to 1. This is true for any angle theta. This is the first identity. Very, very important. It can be proved like this. No need of learning the proof, but it can be proved using any triangle you try with the theta, same angle theta. Sine square 30 plus cos square 30 will be 1. Sine square 60 plus cos square 60 will be 1. Sine square 45 plus cos square 45 will be 1. That means sine square theta plus cos square theta is equal to 1. You have to make it in the box, which shows that it's a main identity. Now, from this identity, we can take derived results. Derived results, matlab, from this you will get two results, namely, first one is, if I am keeping sine square theta here, 1 minus cos square theta, that is 1 minus sine square theta is equal to cos square theta. And second derived result is 1 minus cos square theta is equal to sine square theta. It's nothing new. From this, I am taking one term that side. I'll get 1 minus sine square theta is cos square theta, 1 minus cos square theta is sine square theta. So this is the first identity. Hope you are clear about it. Sin theta likha, cos theta likha, square karke add kiya, I am getting 1. Thus, sin square theta plus cos square theta is equal to 1. This is the first identity. Come to the second one. Using the same triangle we can prove. I am using the same triangle, that is, giving this as theta. This is A, B, C. This is A, this is B and this is C. Now, first I am writing tan theta. What is tan theta? Tan theta, you know, it's opposite side by adjacent side, which is C by A. I am squaring it and adding 1 to it. That is 1 plus tan square theta. हमें क्या मिलेगा? Let's see 1 plus. उसको square करेगा तो C square by A square. Now, I'll take LCM A square. I'll get A square plus C square. You know A square plus C square is B square. So, I am getting B square by A square, which is same as B upon A the whole square. What is B upon A of theta? B upon A is hypotenuse upon adjacent side, which is nothing but sec theta, and B upon A sec theta. So this will come sec square theta. So I am getting the second identity, which is namely 1 plus tan square theta is equal to sec square theta. So please note, this is the second identity. 1 plus tan square theta is equal to sec square theta. From this also we can get two derived results. First one is, what will we get? If we take 1 that side, I will get sec square theta minus 1 is tan square theta. Another one, I will get sec square theta minus tan square theta is 1. Sec square theta minus tan square theta is equal to 1. So the main identity is 1 plus tan square theta is equal to sec square theta. From there we will get two derived results. Sometimes these derived results are useful in order to do the sums. So this is the second identity. The first identity is sin square theta plus cos square theta equal to 1. Second identity is 1 plus tan square theta equal to sec square theta. The same way we can prove the third identity, which is 1 plus cot square theta. 1 plus, what is cot theta? Cot theta is adjacent upon opposite, that is a square by c square. I am taking c square out, LCM. So I will get c square plus a square. You know c square plus a square is b square. B square by c square, which is nothing but b by c the whole square. What is b by c of theta? Theta's b by c is nothing but cosec theta. So I am getting cosec square theta. So I am getting the next identity, nothing but the third identity is 1 plus cot square theta is equal to cosec square theta. So this is the main third identity. 1 plus cot square theta is equal to cosec square theta. From this I can get two derived results, namely cosec square theta minus 1. Cosec square theta minus 1 is equal to cot square theta, and the second derived result is cosec square theta minus cot square theta is equal to 1. So these are the three main identities. Sin square theta plus cos square theta equal to 1. 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. So these three identities you have to learn nicely, and how you are getting it and the derived results. If you know the main results, derived results can be easily obtained. Now, what is the use of this? This trigonometric identities use karke, we have to prove certain results. Prove certain results they will give. We have to prove that the left hand side and the right hand side agrees, or it is, you have to verify certain things. For that, I am giving you some tricks, like, you know the 6 ratios of angle theta, that is sine of an angle, cos of an angle, tan of an angle, cosec, sec and cot. Out of this, the simplest ones are sine theta and cos theta. All the other 4 ratios can be explained in the term, can be expressed in the term of sine theta and cos theta. For example, let me write sine theta and cos theta of an angle. Now the third comes tan theta, which is nothing but it is sine theta upon cos theta. So tan theta can be easily expressed as sine theta upon cos theta. Next comes cosec theta. You know cosec theta can be easily expressed as reciprocal of sine. So it can be expressed as cosec theta is 1 upon sine theta. The same way sec theta can also be obtained as 1 upon cos theta. So sine and cos are the simplest ones. Tan can be expressed as sine upon cos. Cosec can be expressed as 1 upon sine. Sec can be expressed as 1 upon cos. Obviously, cot theta is tan ka reciprocal hai. Cot theta can be expressed as cos theta upon sine theta. So most of the sums can be proved if we change most of the ratios into, the 4 remaining ratios in terms of sine and cos. Then most of the sums we can obtain, and then there is no particular way to go by. It is merely logic to think, start from the LHS, bring it to the RHS or start from the RHS and bring it to the, use logic steps. Identities involved hai to whole square hai to apply those identities, and most of the sums you will get by applying, converting it into sine and cos. So first you have to learn the three identities, and then you have to take down this very clearly. How can we convert everything in terms of sine and cos? Using this, we can easily do the sums which is related with this in the exercise, that is 8.4 exercise. So let us do 8.4 exercise. Exercise 8.4. Look at the first question. Express the trigonometric ratios sin A, sec A and tan A in terms of cot A. Sin A, sec A and tan A in terms of cot A. In terms of cot A. Cot A के terms पे ये तीनों को हमें express करना पड़ेगा. Let's take the first one, tan A, which is very simple. Tan A in terms of cot A, how can we write? You know tan and cot are reciprocal to each other. So I can directly write tan A is nothing but 1 upon cot A. हो गया. So tan A got converted into cot A. Now let's come to sec A. Sec A. You know sec square A is 1 plus tan square A. We know that sec square A is 1 plus tan square A. Just now we learned the identity. The second identity was 1 plus tan square theta is equal to sec square theta. Namely 1 plus tan square A is sec square A. So what would be sec A? It will be under root of 1 plus tan square A. Okay. Now we don't want tan, we want in terms of cot. So let us do this as 1 plus, I can change tan as 1 by cot square A. Now see, sec got converted into cot. In terms of cot, so I am going for LCM. So LCM will be cot square A. So ऊपर क्या आएगा? Cot square A plus 1. Now denominator is perfect square cot square A. I can remove it from the under root. So I can write very clearly cot square A plus 1 upon cot A. So where I have started with, so sec A can easily be expressed as under root of cot square A plus 1 upon cot A. So tan A we expressed as cot A, sec A we expressed as cot A. Now let's come to sin A. How can you express sin A in terms of cot A? Okay, sin A in terms of cot A. Third, I'm starting from here. Sin A. Okay, you know that sin square A is 1 minus cos square A. We have learned the first identity. Now cos can be connected with, no, we have to write in terms of cot. Sin has to be written in terms of cot. Cot. Okay. No need of 1 minus cos square A. Sin square A. Cosec square A. Okay. So I can write sin square A as 1 upon cosec square A. Because you know that sin and cosec are reciprocal to each other. So sin A is 1 upon cosec A. Thus sin square A is 1 upon cosec square A. This you have to take time and understand. The fourth concept is not that easy. Identities, identities take time and learn it and then only approach that exercise. So sin is nothing but cosec ka reciprocal hai. So sin square A is 1 upon cosec square A. And you know the identity of cosec square A is 1 upon 1 plus cot square A. See, sin is reciprocal of cosec, cosec is connected with cot. Now we want sin A to be expressed in terms of sin square A. So sin A will be under root of 1 upon 1 plus cot square A. So you can see sec A is expressed as cot A, tan A is nothing but 1 upon cot A, and sin A is also expressed as under root of 1 upon 1 plus cot square A. Now, second question you can see, write all the other trigonometric ratios of angle A in terms of sec A, all in terms of sec A. So, starting from sine, all the ratios has to be written in terms of sec A. Let's see how it can be done. Let's come to sin A, first one, sin A. How can we express in terms of sec A? You know, sec is the reciprocal of cos. So, sin A can be, you know, sin square A is 1 minus cos square A. So, I can write sin A as under root of 1 minus cos square A. Hope you understood it. Now, cos can be clearly written as sec, that is 1 minus 1 upon sec square A. हो गया sec के term पे. We'll go for LCM, sec square A LCM. It will come sec square A minus 1. So, numerator I can write sec square A minus 1 upon under root of sec square A sec A. So, we got sin A in terms of sec A. Sin A in terms of sec A. Now, come to the second one, that is cos A. Cos A is nothing but the reciprocal of sec A. So, I can write 1 by cos A. Cos A is 1 upon sec A. Now, we know the third one, tan A is nothing but sin A upon cos A. So, if you divide this, tan A is sin A upon cos A. So, sin A is nothing but under root of sec square A minus 1 upon sec A upon cos A is 1 upon sec A. Sec A cancel. What are you getting? Tan A in terms of sec A is under root of sec square A minus 1. So, we got sin A in terms of sec A, cos A in terms of sec A, tan A in terms of sec A. Now, you reverse everything. Now, sin A ka ulta hoga cosec A. So, fourth one will be cosec A is equal to iska ulta. That will come sec A upon under root of sec square A minus 1. Fifth was sec A itself, sec A in terms of sec A. And the sixth one is cot A. Cot A is the reciprocal of tan A, that is 1 upon under root of sec square A minus 1. So, all ratios, sin A, cos A, tan A, cosec A, sec A and cot A, all in terms of sec A, you can see. Sin A is in terms of sec A, cos A in terms of sec A, tan A in terms of sec A, cosec A is reciprocal, sec A itself and cot A. So, the first two questions I think it's clear to you. Now, the third main question, that is evaluate. The third main question is evaluate. First one, sin square 63 plus sin square 27 divided by cos square 17 plus cos square 73. This is connected with, this is identities plus complementary relation. You can clearly see the complementary angles here, 63 and 27. They are complementary pairs. 63 plus 27 is 90. We can easily convert one in terms of the other. So, sin square 63, I am keeping as it is sin square 63 plus sin square 27. Sin theta is cos 90 minus theta divided by, here you can see 17 and 73, they are also complementary pairs. So, I am keeping this as cos square 17 plus cos, I am converting into sin square 90 minus 73. So, they are complementary relation also and identities also you can see. Now, sin square 63 plus cos square 63. You know very clearly sin square theta plus cos square theta is 1. divided by cos square 17 plus sin square 17. Answer would become 1. Next question, you can try 25 and 65. Convert 25 into 65 or 65 into 25, and there you will get an identity. You can do it. So, main question number 3, second one, please do it yourself. Third ka second one. And obviously, main question number 4 also you have to try, because it is a MCQ, you can do it. Now, fifth main question is proving the terms, proving the certain identities use karke hame prove the following identities with the help of the standard identities or any other logical tricks. Few questions are given in textbook. There are many questions to be done. Obviously, examples has to be done. So, let's go to the main question number 5. So, main question number 1, 2, 3, first one I did. 3 ka second one you have to try, and main question number 4, which is MCQ question, that also you have to try. Now, the fifth one I am explaining, main question number 5. We have to prove identity. Look at the first one. Prove that cosec theta minus cot theta the whole square is equal to 1 minus cos theta upon 1 plus cos theta. We have to prove it. As I said, most of the sums you will get if you convert everything in terms of sine and cos. So, let's start with the LHS. The LHS is cosec theta minus cot theta the whole square, and let's use logic. Cosec is nothing but 1 by sine minus cot is nothing but cos upon sine the whole square. Dono ka denominator is same. I am combining it. 1 minus cos theta upon sine theta the whole square. Hope you are clear. LHS I have taken. Cosec I have changed it into 1 by sine. Cot I have changed to cos by sine. Combined kar diya. Now, numerator upon denominator the whole square becomes numerator square upon denominator square. 1 minus cos theta the whole square upon sine square theta. Now, always you have to look into the right side. Where do we want to reach? Otherwise, uske aage bhi aap chal jayenge. So, better you be careful about what do we want. I think something related with this we want. 1 minus cos we require in the numerator. So, usko aise hi rakhenge and come to the sine square. There is no sine square in the answer. So, let us convert the sine square into 1 minus cos square theta. You know, sine square theta is nothing but 1 minus cos square theta. And this 1 minus cos square theta, further it's an identity. It is a square minus b square. A minus b into a plus b. I can factorize it as 1 minus cos theta the whole square. Don't expand but factorize. A square minus b square. I can write 1 minus cos theta into 1 plus cos theta. Now look at this. 1 minus cos theta and 1 plus cos theta. 1 minus cos theta can be cancelled. What is obtaining is the answer 1 minus cos theta upon 1 plus cos theta. That is nothing but our RHS. Please go through this. This is the way to do. LHS we have taken and converted, combined, applied the identity here. Again, arithmetical identity algebraic identity we applied a square minus b square, a minus b, a plus b. One common a minus b got cancelled, and whatever obtaining is our RHS. So, hope you understood the first question. Now, let's do the second one. The textbook NCERT questions you have to do very carefully. After understanding that, after doing the examples, you can easily do the extra questions. We'll be making you do a lot of extra questions. With that, I think you will understand very clearly. Come to the second question of fifth one. Look at the LHS. Cos A upon 1 plus sin A plus 1 plus sin A upon cos A. You have to prove 2 sec A. 2 sec A आपको prove करना है. Okay. Let us take only the LHS. Look at the LHS. LHS में कुछ change करने का ही नहीं. It is in terms of sin and cos, which is the simplest form. In that case, this is also fraction form, this is also fraction form. Obviously, we will go for LCM. So, LHS we will take and let us go for LCM. I have taken LHS. I have started with LHS. Let's see, I am just going for its LCM. 1 plus sin A into cos A. Just into this. Obviously, what will come in the numerator is cos square A. 1 plus sin A into 1 plus sin A will come 1 plus sin A the whole square. It is very clearly, it's an identity A plus B the whole square. So, let us open the bracket. Cos square A plus 1 plus 2 sin A plus sin square A whole upon 1 plus sin A into cos A. I have not done anything, just cos square A as it is, A plus B the whole square apply kiya, A square plus 2AB plus B square. Now you can clearly see an identity here, cos square A plus sin square A, which is 1. This 1 plus 1 becomes 2. So I will get 2 plus 2 sin A upon, don't open the bracket, 1 plus sin A into cos A. Because once you open the bracket, there is no chance of cancelling it. अभी हम बाहर ले सकते हैं न्यूमरेटर से 2 कॉमन, 1 plus sin A upon 1 plus sin A into cos A. You can see the common gets cancelled, 1 plus sin A and 1 plus sin A. What is remaining is 2 upon cos A. You know, denominator 1 upon cos A is sec A. So 1 upon cos A sec A है तो ये ऊपर आ जाएगा. What will you get? 2 sec A, which is nothing R but our RHS. So where we have started, it's nothing to change. It is in terms of the simplest way, sine and cos. So we went for LCM and open kiya, and then we are getting this RHS. Thus most of the sums you can try. Third question, you may try, but I will be explaining you later once the class starts, because it's a big procedure. So we will be explaining you later. And fourth question I will do. Fourth. Certain questions we will do. Certain we will keep it for further. You can try all the worked out examples. Even the third one you can try. It is just converting tan and cot. Tan को sin upon cos में करो, cot को cos upon sin में करो. Just go for LCM and simple arithmetic method. You will get the right side. You may try it. I am doing the fourth question. The LHS is 1 plus sec A upon sec A. And I want to reach to sin square A upon 1 minus cos A. Let's see where we reach. Sec. Sec we can convert it into 1 by cos A. 1 plus 1 by cos A upon 1 by cos A. I would surely go for LCM there. Cos A. ऊपर आपको मिलेगा cos A plus 1 upon, this is 1 by cos A. Cos A cancel, and I am getting cos A plus 1. Okay, got stuck up there. Now you cannot go further to that because cos A is a very simplest one. So let's keep there, that is LHS. Now let's take the RHS. What is the RHS? RHS is sin square A upon 1 minus cos A. That's the RHS. Let's see, are we simplifying this? Are we reaching here? This is our LHS. Keep it there. Now sin square A, there is an identity connected to it. Sin square A is nothing but 1 minus cos square A upon 1 minus cos A. 1 minus cos square A again. It's an algebraic identity. A square minus B square. It can be factorized into 1 minus cos A into 1 plus cos A. Upon, denominator is 1 minus cos A. It can be cancelled, 1 minus cos A. What are we getting? Is nothing but 1 plus cos A, which is RHS, and here it is LHS. So you can verify saying that RHS equal to thus LHS is equal to RHS. LHS and RHS the same, matlab it is verified. See, LHS I have taken I got 1 plus cos A, RHS I have taken, I have reached 1 plus cos A. We have to go ahead logically. There's no way to go by do this, do that. Nahi hai. Now I will be going for 6th question. 6th. The in between ones which I am leaving, you can try. If you are not getting, you can clear it. We can clear it through our WhatsApp group. Come to the 5th question, 6th question, 6th. 6th LHS is under root of 1 plus sin A upon 1 minus sin A. Look, this is also LHS. Nothing can be done. It's in a very simple form. Sin A, nothing to change. Better not to change. In such cases, there is a method known as reciprocal, conjugate of the reciprocal. You must have learned in 9th standard how to rationalize the denominator. Agar denominator root 2 minus 1 hai to uska conjugate se we multiply and divide root 2 plus 1 upon root 2 plus 1. Agar root 3 minus root 2 hai to root 3 plus root 2, root 3 plus root 2 se multiply and divide. The same procedure we will apply, multiplying numerator and denominator by conjugate. Conjugate, you know, it is A plus B's conjugate is A minus B. So 1 minus sin A ka conjugate hai 1 plus sin A. With that we will multiply and divide, but with under root. So I will write multiplying and dividing by under root of 1 plus sin A upon 1 plus sin A. It's a logical thing. Into root 2 upon root 2. Into 5 upon 5. It's same. Into 1 plus sin A upon 1 plus sin A. So I am multiplying with this. So let's see what will happen. 1 plus sin A upon 1 minus sin A into under root of 1 plus sin A upon 1 plus sin A. Look at it. Numerator. Root 2 into root 2 is 2. Root of 1 plus sin A into root of 1 plus sin A is 1 plus sin A. So we get 1 plus sin A upon, look at the denominator, A minus B into A plus B, which becomes A square minus B square. So we'll get under root of 1 minus sin square A. 1 plus sin A upon, what is 1 minus sin square A? It's nothing but cos square A. So cos square A. So what are we getting now? Which is equal to 1 plus sin A upon under root of cos square A is cos A. Now, when you have A plus B upon C, we can always write it as A by C upon B plus B by C. You can split it the same way I am splitting it as 1 by cos A plus sin A by cos A. Again, you have to see what you have to prove. Yes, we are very near to the answer. I just split it 1 by cos A plus sin A by cos A. What is 1 upon cos A? Nothing but sec A plus what is sin A by cos A? Nothing but tan A, and which is RHS. Sec A plus tan A, which is RHS. So this way you can do it, you can understand. 7th one, you can go for an LCM. You can easily do it. 7th one, you can try. Tan is your answer and you can convert 1. Now come to the 8th question. We'll do the 8th question. So before approaching these questions, understanding these ones, do learn this 4th concept very slowly, very carefully, because you have to take time and understand. It will not be done in 1 hour. You may have to take time and understand and then approach these questions. Come to the 8th question. 5th main question, 8th. It is given sin A plus cosec A the whole square plus cos A plus sec A the whole square. You have to prove right side See carefully. 7 plus tan square A plus cot square A. Let's see from where that 7 and tan square A and cot square A will appear. We have only this much in the LHS. So, as it is very clearly given as identity form A plus B the whole square and A plus B the whole square, let's open it. So, I am opening it sin square A plus 2 sin A cosec A 2AB plus B square, which is cosec square A, plus again open it cos square A plus 2 cos A sec A plus sec square A. Now, can we see any identity here? We can see sin square A plus cos square A, which is 1, plus, look at this, what is this? Sin A and cosec A, which is reciprocal to each other. So, I can write 2 sin A into 1 by sin A, plus, now, we don't want cosec square A in the answer, we want cot square A and tan square A. Can I change this as 1 plus cot square A, because cosec square A is 1 plus cot square A, plus, this is gone along with this, okay. 2 cos A sec A, 2 cos A sec A, I can write 2 cos A into 1 by cos A, plus, again sec square A can be changed as 1 plus tan square A. So, I am just using the same boxes here for that you can understand. Cosec square A is converted as 1 plus cot square A, sec square A is converted as 1 plus tan square A, they are identities. Sin square A plus cos square A is 1 and this is reciprocal is being used. You can see where I have underlined 2 sin A into 1 by sin A, here cos A into 1 by cos A. Now, you can see sin A gets cancelled, cos A gets cancelled. Now, what is remaining is 1 plus 2 plus 1 plus cot square A plus 2 plus 1 plus tan square A. Now, you add all the numbers, you will get 1 plus 2, 3, 4, 5, 6, 7. You are very clearly you are getting 7 plus cot square A plus tan square A, which is nothing but RHS. So, what are we doing? What we want in the right side, accordingly we are turning this. So, hope you understood these questions. Now, the remaining 2 or 3 I have left in between, you can take it, you can see it, how it can be done. Before that, I am telling you thoroughly learn identities. Please do the example and please again and again understand the sums which I have explained so that you can easily do the remaining questions. Few I have left out, you can easily do it. Still, if you are not getting, we will be solving it and putting it in the class. So, with this we have completed this lesson, trigonometry lesson. You can see it is very clearly explained in 4 exercises. 8.1, 8.2, 8.3, 8.4. 8.1 is all about basic trigonometric ratios. If you know one ratio, how can you get the other ratios? 8.2 is related with specific angles. Value of 30 degree, 45 degree, 60 degree, 90 degree, that is applied. Third one, 8.3 exercise is all about trigonometric complementary ratios, complementary angles correction, 90 minus theta is applied there. And the fourth exercise is related with trigonometric identities, namely today we learned 3 main identities. First one is sin square theta plus cos square theta is 1. Second one is 1 plus tan square theta is sec square theta. Third one is 1 plus cot square theta is cosec square theta. Uska related identities is used and proved certain result. So, please take time, complete your textbook and we will be giving you extra questions in the next class.